Hi, I am Erdem Bar.
Hi, I am Efekan Turhan. Today we are going to explain time division multiplexing.
History of TDM. Time division multiplexing was first developed for applications in telegraphy to route multiply transmissions simultaneously over a single transmission line. In the 1870s, Emil Bott developed a time multiplexing system of multiple huge telegraph machines. In 1944, the British Army used the wireless set No 10 to multiplex 10 telephone conservation over a microwave relay as far as 50 miles. This allowed commanders in the field to keep in contact with the staff in England across the English Channel. In 1953, a 24-channel time division multiplexer was placed in commercial operation by RCA Communications to send audio information between RCA's facility on Broad Street, New York, their transmitting station at Rocky Point, and the receiving station at the Riverhead, Long Island, New York. The communication was by a microwave system throughout Long Island. The experimental TDM systems was developed by RCA laboratories between 1950 and 1953. In 1962, engineers from Bell Labs developed the first D1 channel banks, which combined 24 digitized voice calls over a four-way copper trunk line between Bell central office analog switches. A channel bank at each end of line allowed the signal line to carry short portings, each one divided by 8 800 of a second, of up to 24 voice calls. In turn, the discrete signals on the trunk line carried 1.544 megabits divided by second divided into 800 spirit frames per second, each composite of 24 contiguous octets and one framic bit. Each octet in a frame carried a signal telephone call. In turn, each of 24 voice calls was encoded into two constant bitrate streams of 64 kilobits divided by second, and converted back to conventional analog signals by the complementary equipment on the receiving end of the trunk line.
Yes, what is the TDM? Time division multiplexing is a method of putting multiple data streams in a single signal by separating the signal into many segments, each having a very short duration. Each individual data stream is resampled at the receiving end based on the timing. TDM is digital multiplexing technique. In TDM, the channel link is not divided on the basis of frequency but on the basis of time. Total time available in the channel is divided between several users. Each user is allotted a particular time interval called time slot or time slice during which the data is transmitted by that user. Thus each sending device takes control of entire bandwidth of the channel for fixed amount of time. In TDM, the data rate capacity of the transmission medium should be greater than the data rate required by sending or receiving devices. In TDM, all the signals to be transmitted are not transmitted simultaneously. Instead, they are transmitted one by one. Each signal will be transmitted for a very short time. One cycle or frame is said to be complete when all the signals are transmitted once on the transmission channel. The TDM system can be used to multiplex analog or digital signals. However, it is more suitable for digital signal multiplexing. The TDM signal is in the form of frames is transmitted on the common communication medium.
How does time division multiplexing work? Step 1. Signal sampling. The signal must first be sampled and digitized to transmit an analog signal over a digital communications channel. The sampling rate needs to be at least twice the highest frequency component of the analog signal to avoid aliasing. The Nyquist-Shannon sampling theorem states that the sampling rate must be equal to or greater than twice the bandwidth of the signal to be sampled. Using Nyquist sampling ensures that each signal is sampled at a frequency sufficient to represent the analog signal accurately. This reduces the likelihood of distortion or interference that can occur during transmission.
Yes, guys, this video link explain to between different TDM, CDM, and FDM. Yes. Step 2. Multiplexing. Once the analog signals have been sampled, they are converted into digital signals and then multiplexed into a signal data stream. The data stream is divided into frames, each further divided into multiplied time slots. The number of time slots per frame is determined by the number of signals that need to be transmitted and the available bandwidth. Each signal is allocated a specific time slot within each frame. Step 3. Synchronization. A clock signal regulates the transmission to ensure that each signal is transmitted in its designed time slot. This clock signal determines the start and of each time slot and ensures that Kane's signal is transmitted at the correct time. Step 4. Transmission. The multiplex digital signal is transmitted over a communication channel such as a coaxial cable or optical fiber. Each time slot carries a portion of the data for a specific signal, and the time slots are transmitted sequentially one after the other.
Step 5. Demultiplexing. The receiver at the other end of the channel receives the transmitted signal and demultiplexes it by separating the individual signals from the time slot. The demultiplexed signal is then passed through a digital to analog converter, which converts the digital signal back into an analog signal. Step 6. Reconstruction. Once the singles have been demultiplexed and reconstructed, they are amplified and filtered to remove any noise or distortion that might have occurred during transmission. These reconstructed signals are then available for processing or further transmission.
PCM TDM multiplexer. Example: in a two-channel PCM TDM carrier system, each channel is sampled alternatively and converted into a PCM mode. While the first channel is sampled and its PCM mode is transmitted, the second channel is sampled and converted into a PCM mode, PCM code. This process continues with samples being taken alternatively from the channels and transmitted as PCM codes. The multiplexer, which has two inputs and one output, functions as a switch. Alternatively, selected channels are connected to the output of the multiplexer. The time required to transmit the samples from both channels is called the frame duration. In a two-channel system, the time allocated to each channel equals half of the total frame duration. During each frame, one sample is taken from each channel. Therefore, the total frame duration is equal to inverse of the sampling rate.
Block block structure of the TDM system. The systems consist of 6 units: control unit, low speed subscriber unit, high speed subscriber unit, switching unit, trunk unit, and power unit. The system is controlled via a local computer. Its modular structure is designed to be adaptable to meet user needs.
Applications of TDM. Telecommunications. The carrier multiply calls over a signal line in both analog and digital telephone systems. In provide branch exchange systems, data communication networks. In wide area network connections to manage data flow in Ethernet and fiber optic networks, satellite communications to transmit multiple signals over a signal satellite channel, radio and television broadcasting, in digital radio and digital television broadcasting, military and aviation applications in radar and air traffic control systems for secure communication and data transmission, centralized systems in industrial automation and control systems, voice and video conferencing systems to allow multiple participants to use the same communication channel.
Advantage and disadvantage of TDM. Advantage: efficient bandwidth utilization. TDM allows multiple signals to be transmitted over a signal communication channel, making better use of available bandwidth. Low signal interference. Since each signal is transmitted at a different time slot, the chance of interference between signals is minimized. Cost effective. By using a signal communication line for multiple signals, TDM reduces the need for separate transmission lines, lowering infrastructure and maintenance cost. Scalability. TDM systems are modular, allowing easy expansion as more channels or devices are added without significant changes to the existing system. Supports both analog and digital signals. TDM can handle both analog and digital data, making it versatile for a wide range of communication systems. Disadvantages: complexity in implementation. TDM systems require complex synchronizing machines to ensure that each signal is correctly transmitted in its assigned time slot, which can make the system harder to implement and maintain. Ineffi- Inefficient for low speed channels. TDM may not be efficient for systems with a mix of high speed and low speed data. Low speed channels might be idle during their allotted time slots, wasting bandwidth. Limited flexibility. Once the time slots are allocated, the system has limited flexibility to adjust for varying traffic routes if a channel has little data to send. Its allocated time slot remains unset, reducing overall efficiency. Delay in real-time application. Time division processes can introduce delays, especially in systems with many channels. This can be problematic for real-time applications such as video or voice communication, where low latency is critical.
There are references. Uh, Thanks for watching, and we are going to show MATLAB analysis. Continue working. Uh, uh, First of all, we are going to use online MATLAB, and This is multiplexing frequency, uh, time vector, and length. Uh, there are three signals. The first signal is uh, sinus wave. Second signal square wave, and uh, third signal is triangular wave. Then TDM signal is zeros, and uh, TDM signal, TDM signal, TDM signal, first signal, second signal, and third signal, and new time vector. Then combine one, two, and three signal. This one. Yes. Thanks for watching. See you.
See you.